Okay, so the investigators expected the control group to adjust their breeding date the next year, whereas the well-fed supplemented group had no reason to change. The report continues, but in the following year, food supplemented females were more out of synchrony with the caterpillar peak than the controls. Here are the data, days behind caterpillar peak. All right, so here's the control, the one that aren't getting food supplementation, and of course the supplemented, right? Carry out an appropriate test and show that it leads to a quoted conclusion. So our state, we want to perform a test at the alpha equals 0.05 significance level of, so H naught will be that the mu of the control group minus the mu of the supplemented group is equal to 0. So there's no difference versus there is a difference, right? That's the alternate hypothesis. So, where, of course, this is the actual mean time breeding for the birds relying on natural food supply, and this is the supplemented, right? We should use a two-sample t-test if the conditions are satisfied. So the first condition is random, and of course this is a randomized comparative experiment, so that's fine. Now, remember for normal, since our sample size is less than 15, we have to determine if the distributions are close to normal. Basically, we're trying to show that there's no outliers and there's only slight skewness or no skewness at all, right? So no significant skewness. As you can see, I already did the one variable statistics on the calculator. So we have X bar. So X bar here, this is for our control group. So this will be 4. Let's see. The standard deviation is 3.11. So 3.11. The minimum is negative 1.2. Quartile 1 for the control is, so quartile 1 is 2.3. The median for the control is 4.6. Quartile 3 for the control is 6. And the max for the control is 7.7. So now let's go ahead and do our outlier test. So that's quartile 1, which is 2.3 minus 1.5 times the IQR, which is going to be 6 minus 2.3. And this becomes negative 3.25, which of course is less than our minimum of C, which was negative 1.2. So no outliers left of the distribution. Now let's check the right. So this will be 6 plus 1.5 times 6 minus 2.3, which gives us 11.55, which is bigger than the max of our control group, right? Which was 7.7. So there are no outliers for the control group distribution. Now, we're going to check for skewness. So we do know that X bar is 4 and the median is 4.6. So there's going to be less skewness, but we're going to see how significant this skewness is, right? So if we were to carry out this, this would be 4 minus 0.5 times 3.11. 4 plus 0.5 times 3.11. And this is equal to 2.445 to 5.55. And as you can see, the median of the control group, so the median was 4.6. And 4.6 is definitely in this interval of 2.445 to 5.55. So this means that it's only slightly left skewed. So slightly left skewed. So no significant skewness. So at least our control group distribution is approximately normal. Now let's check our other one, our supplemented group. So the X bar, so that's these guys over here. Let's scoot up a little bit. So X bar for our control group is 11.3. Our standard deviation is 3.93. The minimum, 5.4. Quartile 1, 7.7. The median, 11.3. Quartile 3, 15.5. And max is 16.5. Okay, let's conduct our outlier test. So this would be 7.7 minus 1.5 times 15.5 minus 7.7, which gives us negative 4, which is less than the minimum of S. Okay, and then for this one, we would be 15.5 plus 1.5 times 15.5 minus 7.7, which gives us our 27.2, which is bigger than our max for the supplemented. So what this tells me is I have no outliers, right? Like up here, I have no outliers, and here I have no outliers. Okay, now check for skewness. All right, so for this distribution, X bar was equal to the median of S, so this implies no skewness, right? So there were no outliers in either distribution and no significant skewness, so this means both distributions are approximately normal. The independent condition, so the number is has to be less than or equal to 1/10 of the total number of birds without supplementation. And of course, the number in the supplemented has to be less than or equal to 1/10 of all birds with supplementation. And I think it's safe to say that both of these conditions are met. So all conditions are met. Okay, so here are the needed things for my t-test, right? So I have the number in the control group, the number in the supplementation group, the means, and the standard deviations. So in order to figure out which degrees of freedom to use, what it is, it's the minimum of the number in the control group and the number in the supplement group minus 1. So the minimum just means the smaller of the two, which is 6. So 6 minus 1 is 5. So here's my formula for the t. This is equal to, so this would be, let's scoot up a little bit, 4 minus 11.3 minus 0 over the square root of, so the standard deviation is 3.11 squared over, this would be 6 plus, this is 3.93 squared over 7, which gives me a negative 3.736. Okay, so let's go ahead and go to our table. So in the table, as you can see, I highlighted these areas. Remember, it was negative 3.7 something, right? It was negative 3.736. So we can see that that would be between this and this right here. So we know that the probability is going to be 0.01 and 0.005. And of course, I do have a t less than, I got the t value for negative, so I would just be looking at this over here, right? like this stuff over here, and my new t would be around here, right? T, negative t, right? Okay, so let me go ahead and go back here. So our p-value is equal to 2 times the probability that t is less than negative 3.736, which, remember, it was between those two values, 0.01 and 0.005. So 0.01, oh, I guess 0.005 first, right? 0.005 less than the p-value, which is less than 0.01, but the p-value is 2 times that probability, so the probability is between these two, but if we want the p-value, we would have to multiply both of these by 2. So that would give us the p-value is between 0.01 and, so p-value, and 0.02. So we can definitely see that the p-value is going to be less than our significance level of 0.05 because it's between these two. So we can conclude, since the p-value is less than 0.05, we reject the null hypothesis, saying that there was no difference between the mean of the control group and the mean of the supplemented group. So we have enough evidence to conclude that there is a difference in the mean time breeding for birds relying on natural food supply and birds without food supplementation.